Hi, in this video I'm going to focus on the estimation of population proportion and specific only to one population. Estimation of population proportion is very similar on the estimation of population mean. That is, we will make use of a sample to get a sample proportion, and we will be constructing a confidence interval around that sample proportion. Let us consider the following topic. Suppose you wanted to know the proportion of the student population in a certain school who believes that COVID-19 is a serious world concern. So here it is clear that what we are after here is a proportion and not an average or a mean. But just like the estimation of population mean, we will be considering a certain population, and that we will be extracting a sample from that population, and we will study this sample so that we can make an inference about the population. So in this study, our main question would be, do you believe that COVID-19 is a serious world concern? So the respondents can simply say yes or say no. So if our goal is to get the number of those people who said yes, then let's say from the respondents, we ask about 50 people. So this 50 is our sample size. Let's call this as n. Then from this 50 people, let's say that 40 of them said yes in answering the question, so let that to be our x. So basically, just like a simple idea of proportion, if the population, or rather if the sample proportion is noted as p hat, then the sample proportion is basically x over n, the number of people who said yes over the sample size. This p hat will be our best point estimate for the population proportion p. Just like the x bar in the mean, x bar is the best point estimate for the population mean mu. So to complete our solution, that means x is 40 divided by 50. 40 over 50 is 4 over 5, and that is equal to 0.8. So our sample proportion is 0.8 or 80%. So this is the best point estimate for the true population proportion. Now next, after getting the sample proportion, we have to create our confidence interval. In the construction of the confidence interval, we should be guided by the following. Now we have to make sure that the sample size is large enough. To check that, we have to compute the following values. That is n times p hat and n times q hat. Q hat is basically the complement of p hat, and that means q hat is equal to 1 minus p hat. These two values should be greater than 5 so that the sample size can be considered as large enough. Why do we have to make sure, or why do we have to ensure that the sample is large enough? That is because of the central limit theorem. The central limit theorem says that if the sample is large enough, then the distribution will be approximately normal. And when the distribution is normal, we can make use of the z value to compute for the confidence interval. To show you the meaning of the first condition, that is n times p hat and n times q hat greater than 5, let us use our previous example. So in our example, we said that n is equal to 50, x is equal to 40. That is why the p hat is equal to 0.80, which came from 40 over 50. Now if p hat is equal to 0.80, that means q hat is equal to 1 minus 0.80 or equal to 0.20. So to check the first condition, we have to compute n times p hat, and that means n is 50 times q hat, which is 0.80. If we compute for 50 times 0.80, 0.80 times 50 is equal to 40, and 40 is greater than 5. So half of the condition is already satisfied. Next to check is n times q hat. That is 50 times 0.20, and 50 times 0.20 is equal to 10, and 10 is greater than 5. Therefore, the sample is large enough. Once this is satisfied, we can now make use of the formula as we can see on the screen. The formula is p hat, the sample proportion, minus the z of alpha over 2, which will depend on the confidence level that you are going to use for the confidence interval. And we have this, the square root of p hat times 1 minus p hat over n. Now if you look at the right side of the formula, these two values are basically the same. It's just that on the right side you add, on the left side you have to subtract. So this will contain, or this will give us the upper limit and the lower limit of the confidence interval. Now another thing about this formula is this whole value from z of alpha over 2 times the square root of p hat times 1 minus p hat over n is our margin of error for the population proportion. So this is margin of error, and in other symbol, this is known to be the E. So in our example, let us say that we want to be 95% confident. So that means we have to create a 95% confidence interval. So if the confidence level is 95%, that means the alpha is 5%, and the alpha over 2 is equal to 2.5%. That means our z of alpha over 2 is the one that corresponds to the 95%, or this is the z of 0.025. Now there's no need for you to find the z of 0.025 using the table, but if you have a list of the values for the 3 most commonly used confidence level, then you can just refer to that table of values. And if you have that copy, the z of 0.025 or the z of alpha over 2 under the 95% confidence interval is 1.96. So let us apply the formula with the corresponding values. P hat is equal to 0.8. Z of alpha over 2 is 1.96. Then the square root of p hat, which is 0.80, times q hat, which is 0.20, over the sample size. Take note, we use n equals 50, so this is over 50. Now on the other side, there's no need for us to do this again, but all we have to do is to change this minus sign with a plus sign when we compute, and we can immediately get the upper limit. So we'll use our calculator to compute for this value. Upon computation, the value of this is equal to 0.6891. So for the meantime, use up to 4 decimal places. Now to get the upper limit, in your calculator you change the minus sign with a plus sign, and when you do that, the value becomes 0.91087 or 0.9. So in percent, in proportion, this is 68.91% up to 91.09%. So that is with 95% confidence level. So that means the proportion of the people who says that they are considering the COVID-19 to be a serious world concern is somewhere between 68.91 up to 91.09 with 95% confidence. So a valid proportion for, or value for the true proportion is, example, could be 70, it could be 80, it could even be 90. But a claim that the proportion is 65 is not a valid claim under the 95% confidence level. So to sum it up, this is what we have done. To find the best point estimate for the population proportion, we have to compute for the sample proportion, which is our p-hat. To get the confidence interval, we have to make sure that the sample size is large enough so that we can say that the distribution is approximately normal based on the central limit theorem. And to show that, we have to compute n times p hat and n times q hat, and those values should be greater than 5. When that condition is satisfied, you proceed by using the formula and take note of all the values that you need for the formula, particularly the confidence level, which will give you the z of alpha over 2, the p hat, which is already known from here, and the 1 minus p hat, which is equal to q hat over the sample size. So again, the other side is just this value, but instead of subtracting from p hat, you add that to the p hat. That means, or with that, it will give you the upper limit and the lower limit of the confidence interval. After getting the interval, know how to interpret the confidence interval that you have obtained. And only those values within the range can be considered as valid based on the confidence level that you have chosen. So from this video, I hope that you now know how to estimate one population proportion and how to make a confidence interval for one population proportion. That's all. Thank you.